Hi, I'm Jaiza.
Hi, I'm Fredliana.
I'm Ain.
Hi, I'm Elena, and here's our presentation.
Explain the meaning of differentiation and what are the techniques of differentiation. Differentiation is a fundamental concept in calculus that deals with the rate at which a quantity changes. In simple terms, it is the process of finding derivative of a function. There are several techniques used to differentiate function depending on the type and combination of terms involved, such as power rule, constant rule, sum and difference rule, product rule, quotient rule, and change rule.
For question 2a, I will explain how to find the derivative of the function. This function is a product of two separate functions. The first function is u equal to 3x squared. The second function is v equal to second x plus 2. Now, let's find the derivative of each part. First, we differentiate u equal to 3x squared and we'll get 6x. Next, we differentiate v equal to second x plus 2. Since it involves a function inside another function, we apply the change rule, use the given formula. And here's the second slide for the solution. So, to differentiate a product of two functions, we use the product rule, like the given formula. Now, we substitute into the product rule formula. Dy per dx equal to 3x squared multiply second x plus 2, 10x plus 2, plus second x plus 2 multiply 6x. So, the final answer is 3x squared second x plus 2, 10x plus 2 plus 6x second x plus 2. And that's the full solution.
Today, I will present the solution for question 2b. I will explain how to differentiate the function y equals to 4x plus 2 over cos x. This is a rational function, or in other words, quotient. So we're gonna use the quotient rule for differentiation. And the formula is dy over dx equals to vu prime minus uv prime over v square, where u is the numerator and the v is the denominator. Now we're gonna identify u and v from our function. Let u equals to 4x plus 2, so the derivative u prime equals to 4. Then let v equals to cos x, so the derivative v prime equals to negative sin x. Next, substitute all these values into the quotient rule formula. Make sure, be careful with sign. Subtracting a negative becomes positive. So this is the final answer, and it shows the derivative of the function using the quotient rule. It's important to be careful with signs and always simplify at the end.
Now, let's look at how we solve the problem using linear approximation. We are given that the value of x is 80.99. Instead of using that, we pick a nearby value that's easier, and we choose x0 equals 81. The function we are using is fx equal 4 root of x minus 2 divided by square root of x. But to make things easier, we change all square roots and fourth roots to exponent notation. So the new equation is fx equals x power 1 over 4 and 2x power negative 1 over 2. First, we substitute 81 into this function to find f81. So we get f81 equals to 81 power 1 over 4 minus 2 times 81 power negative 1 over 2. The answer is 25 over 9. Next, we move to the derivative function. Now, we find the derivative of the function f prime x equals 1 over 4x power negative 3 over 4 plus x power negative 3 over 2. We substitute 81 into the function. So we calculate f prime 81 equals to 1 over 4 times 81 power negative 3 over 4 plus 81 power negative 3 over 2. The answer is 31 over 2916. Alright, now we will use everything we just found to estimate the value of the function at x equals 80.99 using linear approximation. The formula we are using is f(x0) plus delta x equals to f(x0) plus f prime x0 times delta x. We already know x0 equals to 81 and delta x is negative 0.01. Delta x is x minus x0, so 80.99 minus 81 equals to negative 0.01. So f at 81 is 25 over 9 and f prime 81 is 31 over 2916. Now we substitute into the formula. f 80.99 is 25 over 9 plus 31 over 2916 times negative 0.01. The final answer is 2.778. That's all from me. In this assignment, we have explored key concepts and techniques in differential calculus. In part A, we begin by understanding the meaning of differentiation, which is the process of finding the rate at which one quantity changes with respect to another. We apply differentiation techniques such as the product rules, chain rules, and linear approximation to solve various functions. In part B, we choose question 4 and apply linear approximation to estimate the value of square root of 80.99. This method used the tangent line at a known point to approximate value of a function near that point, showing how calculus can simplify complex calculation. Overall, this project strengthened our understanding of how differentiation is applied in solving mathematical problems, both in theory and in real-world approximation. It also enhanced our skills in explaining mathematical process clearly through a video presentation format. That's all from us.